Patients undergoing traditional physical therapy models face barriers to access such as cost, convenience, limited comprehension due to qualitative feedback, and impersonal care as a result of overworked physical therapists. There exists a gap in the market for a device or system that reduces cost to the patient, provides concise, quantitative feedback, and elevates the level of care provided by the physical therapist while increasing the convenience of long-term therapy. Our device uses Intel's SR300 3D camera that the patient will use for all their PT exercises and which will collect the data pertaining to the range of motion and mobility of their joints, as well as swelling. It gives historical information to the patient and in the future may suggest exercises to help shorten recovery time. Our target user is a patient who may be in danger of failing to complete their optimal physical therapy regimen. Failure to complete this PT regimen can create significant long-term health problems, and our device seeks to avert that. voluMETRIC uses a simple user interface to reduce the barrier for patients to use the system. In this case, Kelly wants to perform a swelling test on her recently operated on hand. First, we select the user profile. In this case, it's already been created, and now we can start the test. Here, she has the option of either choosing range of motion or swelling or viewing her existing history. But in this case, we're going to go to swelling. Now, we can start the test. The device will tell Kelly to clear the area below the camera, and then we press OK, and a calibration image is going to be taken. Now, Kelly can place her hand underneath the scanner for the volumetric image to be taken. There's a countdown clock, so patients can visually see how long it's going to take the photo, and then now you can see the photo is taken, and the volume is immediately calculated. Now, we can save the data, and now at this point, we can view Kelly's history. So as you can see, Kelly started out with a very swollen hand in her first session with the system, and over time she's gradually improved as she's gone through her PT process, or in other cases maybe she didn't do as well and it could have gone up. The second test that our system can perform is a range of motion test. In this case, we're performing a range of motion test on Carlos's elbow. So we can select Carlos's profile and press start. Now we go to the range of motion test. Press start test. And the system indicates that the camera will take a photo of Carlos. He now move his arm from top position to the 180-degree position. This is simulating a full range of motion. The camera has now taken the image and selected the 3 dots that correspond to the indicators on his sleeve. Now we will save the data and go to view his previous data. Now, we can see that Carlos started off with a smaller than 90-degree range of motion for his arm. Over the course of therapy, in this case made up, we have sessions 2, 3, and 4, and finally this last session where he had a full 180 degrees of motion. One aspect of our project that we're particularly proud of is the fact that we both took a depth image from the camera, which is difficult to do in the first place, but then also create an algorithm to find the contours or the edges of your hand and then integrate within those contours. You can see in our code down here, we first have to take a photo of your hand, a baseline image, and then do a lot of segmentation and a lot of data calibration in order to get a usable image to take a volume with. Farther down, you can actually see here, a little farther, is the contour finding. And what it does, it just takes the averages of values as you go across the image, and then if there's a large spike, it creates a contour pixel and then plots an actual contour.
We designed the VI in LabVIEW to be as modular as possible to make the addition of new utilities as easy as possible. To accomplish this, we used the tab control. That way, if we wanted to incorporate a new test or new utility into our program, all we had to do was add a new tab. This also compartmentalizes the block diagram by having all of the programming associated with one of the tests placed together in one case structure within the main while loop. We also designed a user management system that associated their data file with their profile in the program. We do this by setting up a directory within the user's computer and reading those files to strip the names from the file and use that as the profile name. This sub-VI automatically checks whether the directory is inside of the user's computer or not, and if it finds that there is no volumetric directory, it creates the architecture of subfolders, such as the patient data and the temporary data cache.
We are volumetric.